In this video, we're going to look at how to complete a hypothesis test for a population proportion, mean, and standard deviation. In your textbook, this is 8.2, 8.3, and 8.4. Now, the hypothesis test for population proportion and for the mean can be done in the calculator, and that's how I'm going to do it in this video. The population standard deviation hypothesis test needs to be done by hand. There may be programs or websites that will do this for you, but I don't have any of those, and so I'm going to do this by hand. The big question I get usually at the end of the chapter is, how do I know what kind of hypothesis test I need to run? How do I know if it's a population proportion? How do I know if it's a mean? And really, it's right in the question. If we look at this question, now I know I have this labeled 8.2, and so we know that this is going to be a population proportion. But you'll be able to tell what's happening by the type of question that you're asked. So it says, consider a drug that's used to help prevent blood clots in certain patients. In clinical trials, among the 60, so N is 6,060, treated with the drug, 164 of the people, so we'll say X is 164, developed an adverse reaction. Use a 0.05 significance level. So alpha is 0.05. And alpha is 0.05 a lot. Sometimes it's 0.01, sometimes it's 0.1, but it's 0.05 most of the time. And then here come the magic words. Test the claim. When you hear test the claim, get your pen ready. If you hear test the claim, that means you have a hypothesis test and not a confidence interval. If it's a confidence interval question, it will say find the confidence interval. If it's a hypothesis test, it will say test the claim. So I'm going to get my pen ready, and it says test the claim that 3% of the users, so 3% we can't work with percent, so I'm going to write that as 0.03. And if you're talking about a percent, you're talking about population proportion. So this is a population proportion question. That 3% of the users develop nausea. So 3% exactly develop the nausea. Then after I write that down, I star it. That way I remember it's the claim. And that will be more important when we get to writing the terms. After I'm done writing that hypothesis, that's my claim, I look at what kind of symbol I have here. And I write the opposite of whatever that symbol is. The opposite of equal to is not equal to. Now I'll label the claims. I'm going to get rid of my arrow. The one with the equal sign is always the null. So that's my null hypothesis. So in this particular question, the null is my claim. That doesn't happen a whole lot, but that's the case here. That means this is the alternate. Remember, the null will always, always, always have the equal sign. If you have a not equal, less than, a greater than, that's always going in the alternate, which is this guy down here. Okay, so now we can finally start the test. We have everything we need. We know it's a population proportion. So I'm going to run a run prop z test. Test because I'm talking about a population test, not a confidence interval. So I'm going to bring up my calculator. Where am I going to put it? I'm going to put it right here. And I'm going to go into stat test, and I'll go to one prop z test. Now for me that's 5. I have an older calculator, you see, so it may look a little bit different on your screen. This kind of looks like a 0 right there, and it is a 0. This is what's in your null. That little 0 here is this little 0 right there. It doesn't say an H, but it says the null for this population proportion type question, and that's a 0.03. X is the number of people that you were measuring, like you were counting up how many people said yes, in this case how many people felt nauseous, how many people went left, whatever the story is, that's the number that goes in there. And 60 was the number of people in our study altogether. The next line, and I know it looks a little weird and it kind of looks a little backwards because of the knots. What you're going to do is match up whatever symbol is in your alternate in your next line here. So I have a not equal to, it's already on the not equal to, so we're good to go there. At this point you can calculate or you can draw. Calculate's going to give you more information, but most of it we don't use. So I'm going to go to draw and I'm going to hit enter and it will slowly fill in. And if you see stuff shaded, that's a good sign that you're going to fail to reject the null. But really what you're looking for is this right here. And I'm going to pull it over so that I can write on it a little bit. This right here is your critical Z. This is your, this is your test statistic. So if you've gone through the PowerPoint, I often talk about the test statistic as the dart. If this lovely little bump was a weird looking dartboard and you threw the test stat at the dartboard, would it land in the section that the alpha is cut off? Now this is a two-tailed test where half of the error, right, half of that is on the left and half of that is on the right. If you threw a dart at the board, would the test stat land in this little red zone? It's hard to tell if you don't know what this cutoff is, and so you would use inverse norm for that. But we can kind of jump over that because we already have a p-value. And so what the p-value method says is if you take your p-value, if the p-value is less than alpha, you reject the null. My little tagline, if the p is low, the null must go. Now here, 0.18 is not less than 0.05. So the p is not low, the null does not go. So in this case, I'm going to fail to reject the null. This is the first part of your conclusion. When you're going through your lab, you'll need to write your two hypotheses. You'll need to gather up this data. And then you're going to need to write a conclusion where this is kind of like 3A. You have to say reject the null or fail to reject the null. And then is the hard part. Then you need the magic sentence. The magic sentence is on the flowchart from the formulas and tables printout that I've been telling you to print out all semester. Looks like this, right? We don't use a lot of this stuff, but you will use A6 in chapter 10, and it may be called A5 or A7 on your fold out. This one is a little bit older. What we're looking for, oh, that's what I'm looking for right here. You start where it says start. Did your claim contain the equality? So this is why I star my little claim. Did the claim, is the star on the thing that says equal to? Yes, it is in this one, which is not too often. So yes, boop, so now I go to this. Did you reject the null? No, we didn't. We failed to reject the null. So the magic sentence is, and let me grab it and bring it over to the other side. There is not sufficient evidence to warrant a rejection of the claim that, I'm going to scoot down a little bit, and I'm going to put this right here. There is not sufficient evidence to warrant the rejection of the claim that 3% of the users develop nausea. And that is how you do a hypothesis test for population proportion. I know the sentence is the hardest part. Star the claim, and then you'll be able to at least answer one of those questions a little bit easier. Now, the good news and the bad news is that the one for the mean really is kind of the same thing. It's good because you don't need to remember another process. It's bad because in the beginning, when you're first getting used to hypothesis testing, they all kind of sound the same. Let's see if we can tell the difference when we go to the next one. Data set about speed dating includes like ratings of male dates made by the female date. So I have my summary statistics. N is 183, so there were 183 people speed dating, I guess. X bar is 5.83. And S, very important that it's an S, is 1.95. S means that we are talking about t-scores here. Now, you can have a situation where you know a population standard deviation, and then you would run a z-test. And there is one in the lab where you do know a population standard deviation. However, I believe so anyway. However, it's not really common. Most of the time you're talking about t-scores when you are doing hypothesis testing, because that's why you're doing the test, right? You want to try to find something out about a population. Alpha is 0.05 again. And we want to test the claim. All right, so that's where you get your pen ready. That the population mean, that's mu, of such ratings is less than 6. That's my claim. The opposite of less than is greater than or equal to. And all I really need is the equal to, because if I say equal to, that's the null. You can put greater than or equal to, you just, or less, no, greater than or equal to, but you don't need to. So that's my null. And here's my alternate, and in this case, my claim is my alternate. So when I go to the little flow chart, and it says, did your original claim contain the equality? No, it did not, because it doesn't say equal to, it says less than. So let's see if we can test this claim. It's going to be a t-test, because we're talking about a mean. It's a t and not a z, because I have S and not sigma. If this said for, I don't know, like somehow they know what every person ever said, that the population standard deviation for the number of likes is 4 or something like that, then that would be a z-test. But we don't have that. We don't have anything that says sigma or population standard deviation. We only got S. So this is a t-test. Now the t-test screen looks a little bit different than the population proportion one. It's still under stat, and it's still under tests, and it's the second one right here. And you see you have two options. You got data and you got stats. Data is when they give you a list of data, and we'll do that next. Right now, we have the stats. So I'm going to click over Blinky and hit enter so it looks a little different. Now, there's my 0, right? But instead of a p, it says mu. That's how we know we're talking about a mean here, right? The number from the alternate, from the null is a 6. The null and the alternate will always have the same number, but we're specifically looking at the null in that question. X bar 5.83, S 1.95, number of people 183. I'm going to match up my symbol, and it's a less than, and it looks like that, right? Exactly the same way. So I'm going to put Blinky on that and hit enter. And I always do draw. I never deal with the calculate. T-scores take a little bit longer. It slowly will shade. And when you see shading, that's a good sign that you're going to fail to reject the null. Not always. But if I was a betting woman, and I am, I'd put my money on fail to reject the null. And I would win. Yay. How do I know that? Because this p-value is 0.1199. 0.12 is bigger than 0.05. Because remember, the magic tagline is, if the null is low, if the p is low, the null must go. The p-value is not low. Is 0.1199 less than 0.05? No. So I'm going to fail to reject again. But I have a different magic sentence, because this time my claim was the alternate. And it may seem a little silly, but when you run these tests, you always test the null directly. So you're not testing always your claim, you're always testing the equal to. And maybe that's your claim and maybe it's not. So when you are writing your responses for what happens, was I right or was I wrong, is not really the question. It's, did you prove this or did you not? And that may or may not be what you wanted to prove in the first place. I'm going to go back to the flowchart. Did my original claim contain the equality? No, it did not. It said less than. That's not equal to. Did we reject the null? No. There is not sufficient sample evidence to support the claim. There is not sufficient sample evidence to support the claim that the population mean of such ratings is less than 6. So it was for this sample, but that doesn't mean it's for all of them. And so that's how you would run the one for the mean, right? It's pretty similar to the one for population proportion. It will look a tiny bit different on the screen when you have the actual data, but it's really the same exact thing. What you'll need to do first is put this data into your list. So let's go over to Stat Edit, and I'm going to put in this data. And then I'll start the question. This is the worst part, putting in data. Okay, data is in, so I'm going to say second mode to go out to the main screen, and a group of students estimate the length of 1 minute without looking at a clock. Use a 0.01, so we want to be like really sure that we are right. Alpha is 0.01, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 students. So it ends 15. And I want to test the claim, so I get the pen ready, that the population mean is equal to 60 seconds. That's my claim. So I got another one where my claim is and the equal. The opposite of equal is not equal. And so here's my null. And here's my alternate. What you're hoping to happen when you're done, great, because you think about that you're holding these in one, right? One's in one hand, one's in the other. And you have to keep one. And so you either say, I'm going to keep this one, or I'm going to throw away the other one. All right, so we're going to be hoping that we say we get to keep the null, right? That's right. If you're going to throw one away and you can only keep one, you want to, you're happy when you can keep the one with the star, because that means you got the answer you were looking for. So we're hoping in this to fail to reject the null. Now I got N. Now notice I don't have X bar and I don't have S. So way back in the beginning of the course, what we would have done is put the data in, just like we did, and then run one vars. But we don't really need to run one vars. You can do that and then write down what X bar and S are, but we can go over to test and go to t-test and then just scoot this guy, boop, back to data, and it will go to L1 and get all that for you. You don't have to do anything with the data. All I need to do is update this bar right here to say 60, because that's the number in the null. And I'll have to go down and scoot this over to not equal to, because that was matches there. Now I'm going to go to draw, and I'm going to really hope that, I see shading. That's a bad sign. Oh wait, no, that's a good sign, right? Because we want to fail to reject the null. We want to keep it. So is the P low? No. Is the P less than, in this case, 0.01? No, the P is not less than 0.01. If the P is low, the null goes. And, well, it doesn't. So that null is not going anywhere. So I have to keep this one, which means this one I got to drop, right? That makes us happy. We got to keep the one that we wanted, because this is not less than 0.01. So we're going to fail to reject. And then we're going to go to the magic sentence. Did your original claim contain the equality? Yes, it did this time again. Did you reject the null? No. There is not sufficient evidence to warrant the rejection of the claim. So basically, I'm not wrong. You don't get to say you're right. You get to say, I'm not wrong. Like somebody did not prove you wrong. So that is the two types that you're going to see in 8.3. Now, if at some point they said, we've been doing this type of study for 30 years and we have 40,000 different counts of when people stopped, and we know a population standard deviation of 5 or something like that. 5? Sure, let's say 5. If I went into here, I would say t-test. And you can see how it looks almost exactly the same, but there's sigma. You'd have to run that sigma in there. Those two will generate very similar results, but they will not be the same. Because remember, a t-score is kind of like a puffy, it's like the stretchy pants of z-scores, right? It gives you just a little bit more wiggle room, but it's not too far off. Now for the one you need to do by hand. Simple random sample of 28 filtered 100 millimeter cigarettes is obtained from a normally distributed population. All right, so we're looking at tar, and it has a sample standard deviation of 0.2. And N was 28, and I want a significance level of 0.05. And I want to test the claim, so I get the pen ready, that the tar content of these cigarettes has a standard deviation, that's sigma, that is different than 0.30. So what does it mean to be different? Like, so you are not 0.3. So you are not equal to 0.3. That's my claim. So this one's a little different than all of the other ones that we've seen. The opposite of not equal to is equal to. Usually we look at it, we say, what's the opposite of equal to? And we get a not equals to. Same scenario, but now my little star is on the alternate. I'm hoping when I'm done that I get something that says reject the null. Because remember, I'm standing here holding these two, and I want to throw this away. I want to keep this one. That's how I get happy. So I can't do this by hand. I can't do this in the calculator, so I have to do this by hand, which is really unfortunate. If you have a not equal to, it's a two-tailed test. All right, so if it was a less than a number, it would be a left tail test, so you'd have just this. And if it was a greater than a number, it would be a right tail test, and so it would just be this. And all the alpha measurement would be wedged in there. Here I have a two-tail test. So much like my confidence intervals, I'm going to take this alpha and I'm going to put half on each side. So I have 0.025 on this side and 0.025 on this side. And I need to find these critical values again, just like you did for your confidence interval. If I have 5% out, then I have 95% in, which means, and actually I am going to change this color to a green. That means the area to the right of this, if I'm sweeping up all of this to the right, I would sweep up the 0.95 and I would sweep up the 0.025, so that would be 0.975. And if I was sweeping up just from here, I would only have this little bit. And those guys have to add up to 100. N was 28, so that means DF is 24. So back to the fold-out card, but now I need to go to the end. And, yep, did it go too far? No, I didn't go far enough. Here we go. Area to the right. Can I squeeze this on? Shoot. All right, so it's way down at the bottom there, 27. And this is the 99 and a half, right? 99. Here's the 975. So I'm going to go down this column. Uh-oh, mailman. And over, and I get a left score of 14573. Ooh. Okay, the Beagle alarm has ended. I think we can resume our question. The mailman lives another day. We had our left hand critical value of 14.573. Let's get the right hand. I need to go to the 27. I was 2 in there, and so now I'm going to be 2 this way. 43.194. 43.194. Well, this barking made me forget. Well, 43.194. Okay, very good. All right, so now if we were doing a confidence interval, these were the two numbers, remember, that went in the denominator. And it would have read something like, find the 95% confidence interval for the population standard deviation. Like, so based on the sample that you have, what do you think is going on with all of the cigarettes in the world? Like, if you were going to pick up a random cigarette and you wanted to make a guess, and you wanted to, about 95% of the cigarettes would have a standard deviation of 0.30. Now we're looking specifically on the outside. So we're not looking at what can I expect to happen. We're looking to see if what is happening is unusual. So confidence intervals say this is what you can expect to happen. Like this is the stuff that usually will occur. When you're having a hypothesis test, you're looking to say, is this unusual? Does it fall outside of the confidence interval? So you could, in theory, find the confidence interval and say, well, no, that's not in there. But then you're doing two steps. So I have these, and now what I need to do is find that test statistic. Remember, here's the dart. If I throw my dart of my sample information that's made up, that's weighted from all my sample information, will it land in the confidence interval? Is it like a normal kind of sample? Or are we being lied to, again, by the cigarette companies and it will land outside? Let's find out. I need to find this formula for my sample statistics. So I'm going to scroll real fast, so close your eyes. So you whoop. And let's see if we can find our test statistic. N minus 1. Well, n minus 1 is 27. And then s squared, where is s? Is 0.2. So I'll need to square that. And then sigma, the number from your null, is 0.3, and I'll need to square that. And let's find the test stat. So I'm going to plug this in. 27 times 0.2 squared, I'll just write it like this, divided by, my calculator is kind of old, so I tend to put things in parentheses just to be on the safe side. And I get a test stat of 12. Oh, so if I throw my dart at the board, does it land in the usual zone? No. It lands here. So those sneaky cigarette companies, well, I guess it was a good sneaky because it lands on the low side. Right? At least we're not getting more tar than we thought we were getting. It lands here. So if you're in the tails, if you're not in the confidence interval, that's where the usual stuff is. This is unusual. And if it's unusual, you're going to reject the null, right? So if you land out here, this is reject the null. The other thing you could have done, and I know that MyLabs Plus tends to prompt you to do, is find the p-value for these things. I hate finding p-values for chi-values because you really need to draw this chart to see which way you're going to run. If I wanted the p-value for 0 up to this 12, remember not negative infinity because chi-values start at 0 and go up to positive infinity, I would have to go into stat. No, I'd have to go into distribution, and I would go to the chi-value CDF, and I would go from 0 to 12, and then I would have to put in my DF, which is 27. And I would get a p-value of 0.0057. Now that is less than 0.05, so you would reject the null. So you can use the p-value this way. If you're like, you know what, I'd rather do that than find these values because these values are confusing. You can find the p-value and use the p-value method. That is totally fine with me. But if you run the wrong way, right, if you don't have the chart and you don't know, do I go from 0 to 12 or do I go from 12 to infinity? If you're not sure what the graph looks like, you may look at the wrong side of the chart. This is going to be a reject the null. Our first reject the null, yes! All right, so back down to the magic chart, which I just passed. Did your original claim contain the equality? Actually, no, right? It was not equal to. That was our claim, not an equal to. The only time you're going to go on the top row is when your null is your claim. The only time you go yes is if you star the null. If you star the alternate, which happens more often than not, you're going to come down this way. Did you reject the null? Yes, we did. The sample data supports the claim. Yay us. The sample data supports the claim that the tar content of filtered 100 millimeter cigarettes has a different standard deviation that is different than 0.30. So I know it took us about 30 minutes to do 4 problems, but we worked a little bit more slowly. As you get practice with these types of things, they do tend to go a little bit quicker and make a little bit more sense over time. But it is kind of a strange process. The lab is going to walk you through 4 or 5, very similar to this. You could do by hand or you can use the calculator. The final exam, you're really just looking for that magic sentence. So you might be able to kind of piecemeal your way through that. And if you have any questions, let me know and we'll look at some more homework samples.